Hello everyone. In this video, we are going to see the preparation of glucose and the reactions of glucose. Let us understand, where is glucose found? Glucose occurs freely in nature as well as in the combined form. Mostly it will be found in sweet fruits and honey, for example, in ripe grapes. Let us see how it is prepared. The first method of preparation of glucose is from a disaccharide, that is cane sugar. The formula of cane sugar we have already seen, it is C12H22O11. What are we going to do to this cane sugar is we are going to boil this in presence of acid, like for example H2SO4 and water. This is called as hydrolysis. The moment we do this, glucose will be formed along with one molecule of fructose. Let us see the reaction. It's very simple. So here we have C12H22O11 sucrose. Boiling it in water in the presence of concentrated H2SO4 will give you one molecule of glucose and one molecule of fructose. That means we will get both of them in same amount. So this is the reaction, and one of them is glucose, that is, it is aldohexose, and the other one is its functional isomer, that is fructose, which is called as ketohexose. We've already studied the meaning of the word aldohexose and ketohexose. That means a 6 carbon containing sugar and an aldehydic functional group, whereas a ketohexose means a 6 carbon containing sugar having a ketonic functional group. So this is the first method, which is important, and it is extremely simple to understand, that the sucrose, which a disaccharide, breaks down to give you two molecules of monosaccharides, glucose and fructose. The second method is an industrial method, where we can see that we are presently going to synthesize glucose on a large scale from starch. We are going to boil this with dilute H2SO4 at 393 Kelvin under pressure. So in exam you can just write high temperature and high pressure also. As we can see, the formula of starch or cellulose is C6H10O5 n number of times, and we are going to boil this with n number of water molecules, and we will get n number of C6H12O6. For example, we had already seen that the number n stands for 100 to 3000. So there is no need of writing any number over there, just we can denote it by n. The next point is that glucose is also known as dextrose. The reason why glucose is known as dextrose is because it is a dextrorotatory compound, which means that it can rotate the plain polarized light towards right hand side, that is towards the clockwise direction. It was assigned the structure given below on the basis of the following evidences. So now we are going to start with the main reactions which are asked in the exam for 1 or 2 marks. Explain the structure of glucose, how and why is it considered to be having a straight chain structure. So let us understand this. Okay, so let us look at the reactions of glucose. So here we have the first reaction of glucose is reduction. The meaning of reduction in this case is going to be addition of hydrogen atoms. So the first reaction, you can see what they have done is they have just showed us the oxygen atoms. Wherever oxygen atoms are there, we are going to remove them, and we're going to add hydrogen atom over there. So this leads to the formation of a hydrocarbon, that is N-hexane, which is a straight chain compound. So this reaction proves that glucose is not a branched compound, it is a straight chain compound. The second reaction is the glucose reacting with hydroxylamine. The formula of hydroxylamine is NH2OH. Now this reaction is shown by those compounds which contain a carbonyl group. The meaning of carbonyl group is C double bond O. So these reactions, if we show it in the exam, it will be like this. So when we show it in the exam, we can show it like this. drawing the structure of glucose as we had discussed in the morning, HOH, HOH, HOH and HOH again. So reacting this with hydrogen cyanide. So what happens is the hydrogen cyanide, of course, it's going to break down into H plus and Cn minus, and the Cn minus is going to attack the carbon atom, and this is the migration or delocalization of electron which is taking place, and the whole structure will now get transferred and transformed like this. It will get CH, and then this part gets converted into O minus, and you have a Cn attached over here. This H plus will be now getting attached over here. Okay, so you can just write it as H. Rest all the structure you can draw the same way as you had drawn the reactant. So it will be HOH, HOH, HOH and HOH. This kind of compound where you can see the cyano group and the hydroxyl group, so this kind of compound is called as cyanohydrin. Okay, so cyanohydrin essentially signifies the presence of Cn and OH, and since this compound is made from glucose, so we can call this as glucose cyanohydrin. Which kind of compounds are going to form cyanohydrins? These compounds which contain carbonyl group. So this is your carbonyl group, and carbonyl group compounds can be either an aldehyde or it can be also a ketone. So this reaction has proven that glucose is containing a carbonyl group, and now we have to prove that it is not a ketone but it is an aldehyde. The next reaction is oxidation reaction. So in this we will use a very weak oxidizing or a mild oxidizing agent like bromine water, which will be able to oxidize only the aldehydic group and not the alcoholic group. So if you use a very mild oxidizing agent, it will oxidize the CHO, whereas if you use a very strong oxidizing agent, it can oxidize the primary alcoholic groups also. And we are already aware that what happens if the alcoholic group gets oxidized. The primary alcohols, if you oxidize them, you get aldehydes, and aldehydes on further oxidation give you carboxylic acids. So in this particular case, since we are using a mild oxidizing agent, we will be getting the CHO getting converted into COH. So this compound is called as gluconic acid. So this reaction proves that the carbonyl group which we have seen in glucose is an aldehyde. The next thing is reaction of glucose with acetic anhydride in the presence of concentrated H2SO4. So this is a kind of reaction which is called as acetylation reaction, and in acetylation reaction we get the formation of glucose pentaacetate. So since it is forming pentaacetate, it shows that it is containing 5 hydroxyl groups. It contains 5 alcoholic or 5 hydroxyl groups. Acetic anhydride formula, everyone is aware of how does it look like. So it will be simply CH3 C double bond O this way. To be writing it in a more proper way, you can write it as CH3CH3. So since we are getting glucose pentaacetate being formed, it is proven that glucose is containing 5 OH group. Let me show you the reaction now once again. So here we have the HOH, HOH, HOH and again HOH, plus we are going to draw here CH2OH, and we're going to do this reaction in the presence of acetic anhydride, which can be written as CH3COO2 times and an oxygen atom in the presence of concentrated H2SO4. This reaction is called as acetylation reaction. Now over here we are going to see that the OH, that is 1, 2, 3, 4 and 5, these OH are going to remove their hydrogen atoms. So wherever hydrogens were there, in its place we are going to write the acetyl group. What is acetyl group? So acetyl group is this group. So the structure will look like this. Let me just finish drawing the structure. Right, so now this was the structure. Now the acetyl portion you'll write like COCH3. Over here also you'll write COCH3, COCH3, COCH3. You can write it in shortcut also, COCH3. So this compound is called as glucose pentacetate. In exam, you may write it in a shortcut also. The next reaction is oxidation with a very strong oxidizing agent. So this is concentrated nitric acid. So it is going to oxidize two things. Number one is the aldehydic group as well as the primary alcoholic group. So as you can see, we have depicted the CHO over here, and these are the OH which are primary. These are the secondary OH and this is the primary OH. So what is happening is the oxidation changes the CHO to COH and all the primary alcoholic group also to the COH. But the point is the secondary alcoholic group, they do not change. This acid is called as saccharic acid, and similarly the gluconic acid also gives rise to the formation of saccharic acid. So this reaction proves that glucose contains a primary alcoholic group in the structure. So here what we have proven now in the exam, what questions will be asked is prove that glucose contains a CHO. So for that we have done two reactions. One is with hydrogen cyanide and the second reaction we did was with the hydroxylamine. So these two reactions happened and we got the formation of cyanohydrogen oxime, and it proved that yes, glucose contains an aldehydic group. Secondly, we also carried out the oxidation of glucose with a mild oxidizing agent bromine water, and we got the formation of gluconic acid. This proved that glucose contains aldehyde. Okay, these two reactions with HCN and NH2OH proved that glucose contains a carbonyl group, and the reaction with the bromine water proved that it contains a it contains an aldehydic group. Next is that to prove that glucose contains a primary alcoholic group, we reacted glucose with concentrated HNO3. When we did so, we got that the aldehydic group got converted into COH as well as the primary alcoholic group got converted into COH. So that compound which we got was dicarboxylic acid called as saccharic acid. Okay, so this reaction proved that glucose contains a primary alcoholic group. The next thing is how do you prove that glucose contains a straight chain compound? We proved it by reacting glucose with a reducing agent like HI, and we got N-hexane. We did not get isohexane or any other branched isomer. Finally, we reacted glucose with acetic anhydride and we got formation of glucose pentacetate, which proved that glucose contains 5 hydroxyl groups. So on the basis of all these reactions, it is proven that glucose has got a straight chain structure of this pattern. Now we've also seen in the previous class that this is going to be a D-glucose because the OH on the last chiral carbon atom is on the right hand side. glucose is also called aldohexose because it contains an aldehydic functional group and 6 carbon atoms. Glucose is correctly named as D plus glucose, and the D, as we have already discussed, it talks about the configuration, whereas the plus stands for the dextrorotatory nature of the molecule, and D and L are completely different. Okay, so what is this D and L standing for? The D and L letters, capital D and capital L, before the name of any biomolecule or a compound indicates that its relative configuration of a particular stereoisomer with respect to the configuration of some other compound. For example, we can see that the reference compound for us is D-glyceraldehyde and L-glyceraldehyde. So in D-glyceraldehyde, you can see that the OH is on the right side, whereas in L-glyceraldehyde, the OH is on the left hand side. Instead of writing L, we can write minus, or instead of writing D, we can write plus. So here we can see what they are mentioning is that all those compounds which can be chemically correlated to D plus isomer of glyceraldehyde are called as D configuration, whereas those which can be correlated to L minus isomer of glyceraldehyde are called as having L configuration. Okay, so the point here is that, so there's a word mentioned in the paragraph, configuration. So the meaning of the word configuration is simply the three-dimensional arrangement of atoms around a given atom. Okay, so this is a comparison of the structure of D-glyceraldehyde and D-glucose. So why is it called D-glucose? Because its configuration or the three-dimensional arrangement on the last chiral carbon atom, that is this carbon atom, is exactly the same as that of the D-glyceraldehyde. So we are just comparing the skeleton of the D-glucose with the skeleton of the D-glyceraldehyde. So once again, we'll just mention this point. D plus glucose, it's called because it's having a D configuration and it's a dextrorotatory compound. So the plus sign stands for dextrorotatory nature. The point which has to be remembered here is that there is no connection between capital D and small d. There is no connection between capital L and small l, right? The capital D stands for the configuration, whereas the small d stands for the optical rotation, that is towards the right hand side or the clockwise direction. The L capital stands for again the configuration, whereas the small l stands for optical rotation, that is anti-clockwise. So I'm sure you have understood this particular topic. How do we prepare glucose and what are the various reactions of glucose which prove that glucose has got a straight chain structure. It has got 5 hydroxyl groups, it has got a carbonyl group, and that also it has got an aldehydic group, and so on. Please revise all these reactions, and it's very important, and of course in every board exam you will definitely see one question on this reaction. So all the best, children, for your board examinations. The next topic we will be seeing in the next video. God bless.